Hello and welcome to another episode of the Omics cast. Today I'm going to talk about Intel Ice Lake announcements. And this is from a blog post on why Ice Lake is important from a bit basher's perspective. And it was written by Jeff Langdale, principal engineer at Intel Corporation in New South Wales in Australia. He's been at Intel for quite a few years now, and he undertook his education at Carnegie Mellon and Sydney University. And so he writes on this blog post about the announcements by Intel at Computex, and Intel has announced what they call the new Ice Lake architecture, ICL, and the Sunny Cove Core SNC. So ICL is what it's going to be mostly covered here by this blog post, and I want to give it a twist on the side of bioinformatics or genomics, since there's been recent announcements of software like BWMM2 that makes use of certain instruction sets that have become popular in recent architectures. And so because Jeff Langdale considers himself a bit basher, he wants to see what we can do with these architectures on the SIMD side of things. Then I thought, since this is relevant for bioinformatics, let's go into the discussion of what ICL brings to the picture. He says Cannon Lake CNL didn't really happen, meaning it was supposed to happen, but they couldn't really release it to the market. They had a few nooks out there, and they give them to some people who did some measurements of VBMI, and then the real transition from AVX2 is what SNC can do, right? Sunny Cove and Ice Lake. So the reason why I got interested about this blog post is for the same reason the author is interested in talking about this. It's because he's not really interested in deep learning, floating point, or crypto. He considers himself a bit basher, and in that respect, this is what he describes in detail in this blog post. And that's something that is relevant to bioinformatics or genomics. So ICL says it will add AVX512 to a consumer chip for the first time, so we can see it on desktops and laptops anytime now. AVX2 was an incremental SSC update, but AVX512, in his opinion, changes things, right? And it does a lot more than an incremental change on SSC or AVX2. He says it allows us to do all sorts of cool things that previously would have required mental gymnastics to do in SIMD. And AVX512 introduces an eight mask registers that are spacious enough to allow most operations to be conditionally controlled by whether the corresponding bit in the mask is in or out, or on or off, including the ability to suppress loads and stores that might otherwise introduce faults. So because of these generous registers, mask registers, now we have a lot more flexibility in what we can do. This is a picture I pulled out, and it basically shows that the 512 AVX allows you to have a lot more flexibility in what you do, and the blog post goes into detail into it. So SNC, interesting add-ons, and they describe which ones. Many of them, but the two that I'm going to highlight that are highlighted here is VBMI2 and GFNI. And they say, or in the blog post, they say that Intel hasn't released all the information yet in PDFs, but that they hope this will happen soon. So VBMI adds a capability to dynamically, rather than through a fixed pattern shuffle, dynamically shuffle bytes as well as words, what they call double words or quad words in 32 or 64-bit Intel S parlance. The shuffles can have two register forms, so you can pull in values over the 512 B pairs of registers. talks about some other considerations here. And so generically, if these shuffle instructions are table lookups, the byte operations of these new instruction set allow you to look up 64 different bytes at once out of a 64-byte table, or 64 different bytes at once out of a 128-byte table in the two register forms, right? And he says that the throughput and latency costs are fairly good, right? So he expects this to be relatively cheap for SNC, based on what Cannon Lake was, right? And so he says, new operations that are not very latency costly and they give people flexibility. And the other one is GFNI, and he says, I don't care about crypto, but GFNI has an angle that would be of interest to people that are essentially bit bashers. And he himself confesses that for some of these, he doesn't have all the information. So he's like a monkey with a stick, like this one. So this rather difficult to spell instruction takes its 8-bit value and matrix multiplies it in a careless way. And so it's, in his opinion, an 8-bit shift and rotate, not operations that existed on Intel SIMD otherwise, which allows these matrix multiplications and the flexibility in the size of the submatrix that you multiply to do clever things with it. The second one uses SIMD registers to hold the results of 64 by 64 into a 128 multiply, which he says looks like a good substitute for some of the PEXTs, right? It says it's not, but it could be a good substitute for the PEXTs. And so if Intel had vectorized PEXTs, this would be very easy, but he says this could go quite far along those lines. And so his conclusion is that for people that are integer focused, ICL and SNC are something to look for and to start investigating and to start adapting code, seeing if code that has been written could take advantage of this. Adds a huge collection of instructions that allow us, in many cases for the first time, to move bits and bytes around within SIMD registers in complex and useful ways, in the matrix multiplication or lookup tables, etc. And so he says this kind of SIMD programming is hugely important. There are plenty of ways to do bulk data processing on SIMDs, on GPUs. And this approach is a traditional, well, I had to multiply a huge vector by a huge matrix type problem, which has setup costs, latencies, etc. But he says, at the end, if you have all these operations with relatively low latency, you can amortize over thousands of elements. And so an interesting post that describes what could be coming from these new Intel platforms that were announced at Computex, and that I think those are relevant for bioinformatics. If you like videocasts like this, follow me on Twitter, twitter.com/AlbertoVilella. And also, I encourage you to also ask me questions on LinkedIn if you want, contact me through it. I'll try and answer all the questions that you have. And this slide deck is available upon request. Until next time, goodbye.